yesterday classes we have discussed about the continuation in second class of solution. So this is the third class. So yesterday we discussed the effect how the solute dissolves in a liquid solvent. So today we will discuss the next one, that is solute is a gaseous and solvent is a liquid. Means the factors which are influencing for the solubility of gaseous solute in liquid solvent. So their solute is a gas and solvent is a liquid. So here, what are the factors under the increase or decrease the solubility of gaseous compound in a liquid? So generally it will be asked for 1 marks. Write the factors which influences the solubility of gas in a liquid solvent. So there are mainly 3 factors. That is, one is nature of the gas. Factors influencing is, one is nature of the gas. Second one is the temperature. Third one is pressure. Means effect of temperature. Next one is effect of pressure. These are the 3 terms which are influences the solubility of solute gas in a liquid solvent. So here, first one is nature of the gas. How the nature of the gas influences on the solubility of gas means, if the gaseous compound are polar, then it is soluble in the polar solvent. You should remember this one. In the last class we have discussed polar compound are soluble in polar solvent and non-polar compounds are soluble in non-polar. What is polar, what is non-polar, we have discussed in the class. So here nature of the gas, if the gaseous compound are polar, which exhibits the dipole. So polar compounds are soluble in water. It is soluble in water, and the non-polar gaseous compounds are insoluble in water. So otherwise we can say, means polar gaseous compounds are soluble in water and non-polar gaseous compounds are soluble in non-polar solvent. What is non-polar solvent? Non-polar solvents are nothing but those are the organic compound, means benzene or benzene derivatives. Those are called as non-polar solvent. Are you getting this one? This is how we have to remember the key points. Polar soluble in polar, non-polar are soluble in non-polar. So here the nature of the gas means polar gases compound are soluble in water and non-polar gases compound are insoluble in water. It means polar gases compound are insoluble in an organic solvent, means non-polar. Similarly, non-polar gases compound are soluble in polar, means inorganic. Are you getting this point? So don't get confused. This is very simple. Understand the concept. So next one, what is the effect of temperature in the solubility of gas in a liquid? So here I say, as the temperature increases, whether the solubility, means the dissolution of gas in a liquid, whether it is increases or not. So first thing, you have to clear in your mind whether the solubility of gas in liquid is it endothermic or exothermic. So I hope you remembering, as we increase the temperature, it is converting solid to liquid and liquid to the gaseous. Means gaseous compounds are existing in the high temperature. At the high temperature it exists. If we again increases the temperature, means it never comes to the liquid state. Means we can get the gaseous compound in the liquid state only by reducing the temperature. Otherwise it's not coming to the liquid state. I hope this is fundamental things for you. It's the same thing. So it means that the gaseous compound, means the dissolution of gas in a liquid, it is a exothermic process. Exothermic is nothing but it liberates the heat. Means gases, when we are dissolving in a solvent, that is liquid compound, it is a exothermic. If you increases the temperature means it do not undergo the dissolution because it is a exothermic. Therefore, in the exothermic, the dissolution of the gaseous compound in a liquid, it is decreases by increasing the temperature. Means as the temperature increases, the dissolution of gaseous compound in a liquid it decreases. Or in other words, by reducing the temperature, we can increase the dissolution of gas in liquid. Why? Because the dissolution of gas in a liquid is an exothermic process. Why? Because as we increases the temperature, the gaseous molecule undergo greater kinetic energy. Kinetic energy will be increases, means they will begin to run. The molecules undergo the fast movement. So at that time, it undergo the tendency, it have the chance to escape from the liquid solvent. Therefore, we are not supposed to increase the temperature. In the lower temperature, we have to dissolve the gaseous compound so that it will dissolve. Therefore, as the temperature increases, the dissolution of gas in liquid decreases. Why? Because it's an exothermic. If we increase the temperature, the gaseous molecule undergo the greater kinetic energy, and there is a escaping probability is greater for gaseous in a liquid solvent. So this is the second term, and third term is effect of pressure. So it is reverse of temperature, means as we apply the pressure, so by applying the pressure, we can convert gaseous into the liquid. Again, by applying the pressure, we can convert liquid into the solid. This is also a fundamental thing. As we increases the pressure, the liquid molecules which are having the greater distance, they come near. So it means it is going to form a liquid state. So again, by applying the pressure, the liquid compounds have the tendency to form the solid structure. So it means as the pressure increases, we can convert gases into the liquid. Why we are discussing about the pressure means, if the pressure increases means we can convert gaseous compound into the liquid, so that liquid in a liquid it will dissolve easier. It is the best method and we can dissolve it in a faster moment. Therefore, as the pressure increases, the dissolution of gas in a liquid increases. Keep in your mind, it will be asked for 1 mark how the effect of pressure varies in the dissolution of gas in liquid. Therefore, they may ask individually or they may ask the points, right, the factors which are influencing. So like that they may ask. So this will be asked for you in the annual exam also. So this is important. And based on this, we are going to discuss the Henry's law. These 3 points are important. Keep in your mind. Next one is Henry's law. So Henry is the name of the scientist. So it will be asked for 1 mark. Commonly state Henry's law. Otherwise, according with the definition, they are going to ask you the mathematical expression. It is simply a formula to write the Henry's law. So if they ask you to state the Henry's law, then you have to write that for 1 mark. Along with the Henry's law, write the mathematical expression means, or simply they give you explain the Henry's law. You should be capable to write the formulas. Okay. So Henry law or Henry's law. So what he is going to explain is, he is going to explain the same thing what we just discussed, that is dissolution of gaseous compound in a liquid. He is going to give some theoretical concepts. So Henry is a scientist going to explain that, means if we want to dissolve the gaseous compound, in a liquid solvent, what we have to do is we have to apply the pressure. So if we apply the pressure means the gaseous compound is going to convert as a liquid in the liquid. So we can easily dissolve this gases in liquid solvent. So based on this concept, he is explaining that according to the Henry's law states that the partial pressure of the gas, means how much we are applying the pressure of the gas, is directly proportional to the mole fraction of the gaseous compound which is present in a or which is dissolved in a solvent to form as a solution. Means the number of gaseous compound which are present in a solution. This is the solution. After adding the solute in a solvent, it's going to form the solution. How many number of moles of solute is present in a solution? Solute is present in a solution. X is nothing but number of moles of solute. Number of moles of solute in a solution. In a solution is directly proportional to the partial pressure of the gas. If we are applying the greater pressure on the gas, we are getting the larger number of gases particles in a solution. If we are applying the lesser pressure in the gas, so that the dissolution of the gaseous compound in the liquid is lesser. So it means that if we apply the greater pressure, we are going to observe greater number of the gaseous molecule in a solution. That is why means Henry's law stated that the partial pressure of the gas above its solution is directly proportional to the number of moles of the gaseous compound present in the solution. So partial pressure of the gas is directly proportional to the mole fraction of the solute present in the solution. So here P is nothing but partial pressure is directly proportional to the X is nothing but mole fraction. If P proportional will be represented or replaced by the constant. The constant is capital K, capital H, but it is subscription. P is equal to pH into X. Whereas this KH, this is itself is called as Henry's constant. This is called as Henry's constant. But they have not mentioned the value. What is the value of Henry's constant? So P is equal to pH into X. This is Henry's constant. This is the mathematical expression. So according to the Henry's law, as the pressure increases, mole fraction of the solute in a solution increases. That can be represented in the graph is. So this is x-axis, this is y-axis. We can take along the x-axis as the pressure increases, number of mole, means mole fraction should increase. Therefore, we are going to get a straight line. So this straight line indicates that as the pressure increases, means partial pressure of the gas increases, there will be a linear increase in the mole fraction of solute in a solution. So this is the graph. Sometimes they will ask you in the previous question of the result on the rest of the class. So you should remember it is not the tough one. But moreover, this expression is important. Whenever you are writing the Henry's law, means statement, must and should remember to write this expression also. So it will be important. So the more important is application of Henry's law. So it will be definitely asked, but sometimes it is asked for the applied portion. Means they are not asking you directly write the applications of Henry's law, give any one application. No, they are not asking that way. They will ask you. They are going to give some of the example. Based on that, you should be capable to write the which law is applicable in that example. So first one is application of Henry's law. This is application of Henry's law. So what he is going to explain is, so already we are not moving away from this one. That is partial pressure is directly proportional to the mole fraction of solute in a solution. So how is, if we want to produce a soda water, what is soda water? The water which is containing the carbon dioxide is called as soda water. So if we make a soda, which we are making in a bakery, so that the bakery containing the soda water means soda, that the soda is something like soda water, means we are preparing the soda by adding carbon dioxide. They are going to dissolve the carbon dioxide in a water, so that water itself is called as soda water. So soda water can be prepared by dissolving the carbon dioxide in water, whereas carbon dioxide is a gaseous compound. It will be dissolved in water. So this is the process to prepare soda water. How they have prepared means in the preparation of soda water, the more application is toward enriched water. How? Because as we apply the pressure on the gas, it is going to dissolve in the water so that we can get easily soda water. Means to create the soda water, they are dissolving the carbon dioxide in a high pressure. By applying the high pressure in a sealed bottle, they are mixing the carbon dioxide in water so that they are going to get the soda as a soda water. Are you getting this one? So in the preparation of soda water, this takes a major role. This is first application. The second one is scuba diver. This is first one. Second one is scuba diver. It's not only the diver, it's the divers. Scuba divers means swimmer. Those are called as divers. Swimmers. Scuba is the one. These are the swimming pool, not only swimming pool. Those are swimming in a sea water. Samudradalli swim ಮಾಡ್ತಿರ್ತಾರೆ ಯಾರು ಹೋಗ್ತಿರ್ತಾರೆ they are moving along with the oxygen cylinder and by protecting them some of the gases come out, and by they are having to their legs they are having some place so that to lift their body easily. So this is the some phenomena, these are the some imaginations of the scuba. ಸಮುದ್ರದಲ್ಲಿ ಸ್ವಿಮ್ಮಿಂಗ್ ಮಾಡ್ತಿರ್ತಾರಲ್ಲ ನಾವು ನ್ಯಾಷನಲ್ ಜಿಯೋಗ್ರಫಿ ಚಾನಲ್ಸ್ ಅಲ್ಲಿ ನೋಡಿರ್ತೀವಿ. So those fellows are called as scuba divers. So here scuba divers containing the cylinder, that the cylinder is containing the oxygen. They are taking the oxygen because they are going to swim, they are going to be inside the sea around more than 1 hour because they are under some searching process. So whichever they are taking the cylinder, that the cylinder is containing the oxygen cylinder. So keep in your mind, whichever we are using the oxygen cylinder, that oxygen cylinder, it's not containing only oxygen. Some of the nitrogen gas will be mixed in a oxygen because we are not taking the pure oxygen. After that oxygen, nitrogen will be taking because we are under the impure oxygen because we are taking already. So that cylinder is containing oxygen. That oxygen is also present in nitrogen. One thing, and one more thing is more important. This cylinder which is containing the oxygen, they are not only mixing the oxygen, that oxygen is mixed by and they are also dissolving helium gas is produced. Why? Because they are going to dissolve this helium. Why? Because they should not want to dissolve this oxygen directly with the nitrogen. Nitrogen is nothing but while we are taking the oxygen in our body by breathing, that oxygen should not be reacting to the nitrogen, whereas nitrogen which is present in our blood means blood containing the hemoglobin. So by a student they will get confusion. So don't worry, in our human body blood is there, the blood containing the hemoglobin. I think I suppose that hemoglobin is one of the compound which is containing the iron, and also that the blood is containing the nitrogen also. That the nitrogen compound should not react with the oxygen. Why? Because when they move inside the sea, there is a pressure increases. As the pressure increases, the gaseous molecule should not mix with the nitrogen or directly to the blood contents. They should move only to our body as a for the respiration purpose. If they dissolve in the blood means there will be a some disease or something will be happens in a wrong way. Therefore, to reduce that dissolution of oxygen into the nitrogen, we are neutralizing the oxygen by dissolving the helium. Why we are adding the helium means just to make the oxygen to not make it as a pressure. Means even though we have applied the pressure, the oxygen should not get a liquid state or should not react, should not mix easily with the nitrogen or any other compound present in the hemoglobin, means in the blood. For that reason, in the cylinder. Along with the oxygen, we are adding the helium gas just to maintain the pressure of the oxygen in the cylinder when that cylinder is taken by the scuba divers. I hope this is clear for you. The scuba divers are using the cylinder, that cylinder containing oxygen. That oxygen is also containing the helium only because to maintain the pressure of the cylinder. Okay. If the pressure increases in the oxygen, there is a tendency to mix the oxygen with hydrogen. Therefore, to reduce that one, we are using the helium gas in the cylinder. This is the second application. If we not uses the helium, there is a tendency to form the risk of bends. Means some of the bones are that will be stuck up. It will be undergo some diseases. Therefore, to come out of that, we are using this helium gas, and whichever I have explained this nitrogen gas is present. We are not taking in breathing, even some oxygens are containing nitrogen, but you are not supposed to write these all things. Only you have to write to the point why we are using this helium in the oxygen. What will happen if we are not using the helium? This is how we have to explain. My explanation is only to understand for you. I hope, and I am sending you the notes based on those who are sending the notes. Only for them I am sending today. So you just write this one. I am sending the overall chapters. So next one is, this is about Henry's law and applications. Next one is equilibrium. So I hope you know what is equilibrium. Equilibrium is the event formation of value. So here, equilibrium vapor pressure of liquid. Equilibrium vapor pressure of liquid. Here we are writing the equilibrium vapor pressure of liquid means when we apply the vapor pressure, means in the liquid. This is again liquid, and we are adding some of the gaseous compound. By adding the gaseous compound, we are applying the pressures on the gas. Means that the gas, it may be in the form of vapor. Vapor is one of the form of water that exists in gases. So we are not saying the gaseous in the gaseous form of water itself. We are calling as vapor. There is some difference between vapor and gases. Why we are using that word means the water in the gaseous form we are calling that as vapor. Why? Because in the normal room temperature, if the compound exists in the liquid, then we have to use that as a vapor. In the normal room temperature, if the compound exists in the gaseous, then we have to use the word gas. Are you getting my point? Hydrogen, oxygen, nitrogen, these are the gaseous compounds. We are not calling that as a vapor. But water we are calling as a vapor. Why? Because in the normal room temperature, it is exist in the liquid. But as we increase the temperature, it is shifting. By reducing the temperature, again it is coming to the liquid. For that reason, the water is undergo the vapor form, not a gaseous form. You should keep in your mind. So why I am explaining this? The vapor pressure means we are applying the pressure on this vapor so that we can dissolve the liquid compound. In the previous Henry's law, we have discussed the same concept, but it is based on the gaseous. You should remember that one. And it's based on the gases. Means we are applying the partial pressure of the gas. On the gas, we are applying the partial pressure. Here we are applying the pressure on the vapor. On the vapor, I think you can able to understand the what is gas and vapor difference. So here we are applying the vapor pressure on applying the vapor pressure. So how these are going to dissolve in a liquid. So this can be explained by Rolle's law. R-A-U-L-T-S. Rolle's law. R-A-O-U-L-T-S. Rolle's law. So whenever you are observing the video, my suggestion is simultaneously you have to make some notes so that it will be easier for you to understand and at least to compare. So which one is there in the notes? Something apart from that one I am explaining your ideas, so that better in any book you got that. So here state the Rolle's law. It will be asking for 1 marks and sometimes it will be asked for 2 marks. State the Rolle's law and write the mathematical expression. Same as it is we have discussed in the Henry's law. There is not much difference between the Henry's and Rolle's law. Why? Because these two are almost similar. Only one term is excess here. So what is that means? Can you see here also we are having the same thing. P is directly proportional to the x. There is no difference. P is nothing but partial pressure of the. It's not on gas. It's on the vapor pressure. Means partial pressure of is a partial vapor pressure of some component. Some component means that is component A is directly proportional to the mole fraction of that component. If it is taken A means it will be the mole fraction of A in the solution. So why we are taking A and B means take that these are the gaseous components. If the gaseous components are 2 A, B, and we are dissolving that in a liquid components. So after dissolving that one, how much we have applied the pressure on the A? How much we have applied the pressure means partial pressure of A. We have applied some pressure. How much we have applied the partial pressure on the A? That much of mole fraction of compound A will be present in the solution. Will be present in the component means mole fraction of component A is depends on the partial pressure we apply on the component A. Are you getting this one? There we have discussed only one gas. Here we are discussing more than one gas. So same thing here also. PA proportional is written as is equal to, then instead of proportional we are writing the proportional function, that is PA naught into XA. Here PA is nothing but partial pressure of component A. Partial pressure of component A. PA naught is nothing but partial pressure of pure component A. Pure component A. So whereas XA is nothing but number of moles of component A in the solution. Number of moles of component A in the solution. Similarly, I said that if it is component A, if it is having another component, then we are calling. Similarly, PB, partial pressure of B, component B is directly proportional to the mole fraction of component B. Therefore, directly I will write PB is equal to PB naught into XB. Same thing here also. PB is the partial pressure of component B. PB naught is the partial pressure of pure component B. XB is the number of moles of component B. So here XA and XB are the mole fractions. Mole fraction of component A. XA and XB are the mole fraction of component A. If the gaseous component are containing two components, XA and XB, AB, mole fraction of component A, this is mole fraction of component B. If two components are there, together mole fraction of all the gaseous component is always 1. Means mole fraction of individual gases together, the sum of individual gases is always 1. I have taken as two gases are there, means two partial compounds A and B. The mole fraction of A plus mole fraction of B, together it should be unity. If it is 4 means together all the sum of mole fraction of 4 component, the mole fraction is always, sum of all the gases will be unity. It will be 1. So based on that, it will be helps to calculate in the problems. Means XA can be written as 1 as XB. So in the notes I am giving some of the formula. So those are not important. These three are important, and you have to remember this one. XA plus XB is equal to 1, because mole fraction of A and B together it will be always unity. Means all the mole fraction is 1. And there is a one graph. So what is the means? When we are using the mole fraction of component PA, the mole fraction of pure component is decreases and PB is increases. So how, on what basis means? Comparing to the pure compounds XA and XB, there is one graph. We just go through that graph. That graph is very simple. By observing that one, you can able to understand. So why I am not explaining, why I am not writing, it's not important for the examination one. So that's why here this is the most important. The statement is important and the expression is important, and it is more important while doing the problems, because soon these ones we are having the problems. So this is important. So we will see the next problem or the theoretical parts in the next classes. So until then, have a nice day. If you are having any doubts, feel free to ask.